Okay, in this video we're going to look at another way of storing signed integers, and this method is called 2's complement. Um, so the previous method that we've looked at, sign and magnitude, uses two parts, a sign and a magnitude, to represent a number. Now what 2's complement attempts to do is to just use one whole value, and the sign is still recorded, but it becomes part of the number, which means when you're doing arithmetic, you don't even have to look at the sign. You just get on with arithmetic, and you'll see that in another video. Okay, but let's have a look at the process of 2's complement. It's got a weird name, and because it's called 2's complement because it's a two-step process. There is to write down positive numbers is simple, it's identical to sign and magnitude, but to write down negative numbers, you have to go through the 2's complement process. If you want to know why we use 2's complement, it's because it allows you to do addition and subtraction without having to create any subtraction code or any subtraction hardware. So you can do addition by doing subtraction. Okay, but I'll talk a little bit more about that when we do the addition work. So let's just have a look at the format first. So let's, as we were before, let's use an 8-bit number. So we have, let's put some column headings down. So just 8 column headings, doubling up each time, nice and simple. Okay, just like sign and magnitude, it uses the most significant bit. Remember, this is the one with the largest column heading as the sign bit. So this again is going to be our sign bit. Okay, so for positive numbers, the process is identical. So let's say we wanted to write down the number plus 45. Okay, we start with the sign. The sign is positive. So just like in sign and magnitude, we put a 0 in the sign bit to mean positive. And then we use the remaining bits in order to represent the size, the magnitude, so the 45. So let's do that. So we can't have any 64s, but we can have a 32. That will leave me with 13. So 16 isn't going to go, but 8 is. 8 from 13 leaves me with 5. So I've got a 4 and a 1. So that in 2's complement is plus 45. Now, when you read these numbers back, if you're told you've got a signed number, you can always look at the sign bit and say, oh, look, that's a positive number. If it was a 1, you could say it was a negative number. But you must be careful, okay? And you must make sure, because there's more than one way of writing signed integers, you must read a question carefully. If it says it's in sign and magnitude, then you must use the sign and magnitude methods. If it says it's in 2's complement, then you have to use the 2's complement methods. Okay, so that's the positive number. Now, when we did sign and magnitude, if I wanted to write down minus 45, I would just change the sign bit and the rest of the number would stay the same. But 2's complement doesn't work like that. What we have to do, if I want to write down what minus 45 is, my starting point is to say it's negative. Okay, 2's complement. And I should always say cannot write down straight away. That's what I must say to myself. So we don't know how to write negative numbers. There is a way of doing it, but I'm not going to teach you because it's complicated. If you want to know how to directly write them down, go and look it up. Okay. Right. So what we do, if we want to write down a negative value, what we do is you say, okay, hang a minute. Let's write down the positive value. And then this process, 2's complement, will convert a positive value into a negative value. Okay, sounds a bit weird, but it's actually more difficult to explain than it is to actually just do. So let's have a look. Minus 45. So I don't know how to write down minus 45. So what I'm going to write down is plus 45. Now I've already written that, but I'm going to write it again. So I'm going to write down. So step 1. write the positive number down. So using this, I'm going to write down a signed bit of 0, which proves it's a positive number, and then I'm going to write 45. So I'm just going to actually copy what we've got above. Okay, and then I'm going to do 2's complement, which is a two-step process. There is a flip and an add. Okay, so I'm going to show you how to do that. So step 2. So we flip the number. So we've written down positive 45. And I'm going to make a little note at the side just to say, right, I know that's not what I was doing. That's where I'm starting. Right, so I'm going to flip all the bits. So when they're a 0, they become a 1. And where they're a 1, they become a 0. So that's the complement. And then the final step is we add 1. So that was the flip phase. Step 3 is to add 1. So in binary, to add 1 is quite straightforward. We just work from this way, and the first time we find a 0, we change it to a 1. Anything we've gone past, which is nothing in this case, we write down as zeros. So we can just say, right, well, there's 1, and then everything else just stays the same. So that's how you quickly add 1 in binary. Okay, so that is now minus 45. Not very easy to read, but you can see that the sign bit is 1. Okay, so you know it's a negative number, but it's really important that everything that we store in the computer is in binary. So this could be a signed integer, it could be an unsigned integer, it could be a character, it could be a pixel color, it could be the amount of green in an image, it could be the amplitude of a channel in an audio recording. Okay, unless we know what the format is, we cannot interpret that data. So it's really important. So let's just verify to ourselves that this is actually minus 45. Right, 2's complement. It's similar to the mathematical operation of timesing a value by minus 1. And you can see effectively that's what we did. We wrote down positive 45, and then we've done 2's complement, which is sort of turned it into multiplied it by minus 1 because it's now minus 45. But the weird thing about multiplying by minus 1, if I take minus 45 and multiply it by minus 1, I should get 45. So what I'm saying is, if I perform 2's complement on this number, I should be able to find out if it was 45. So I'm going to perform 2's complement again on this number. And I'm going to show you an easier way to do the flip and add 1. You can do it all in one go. Right, so I'm going to just verify that I've got minus 45. So let's just scroll that up a little bit. Right, so what I'm going to do this time, I'm going to flip like I did before, but this time when I get to the last 1, I'm going to leave that as a 1, and then anything that follows I'm going to write down as 0. So I'm sort of like doing the add in the same step. Okay, so I'm going to go flip, flip, flip. You've got to try not to say Philip when you're doing that. When your mouth goes dry, you can sometimes say Philip. Flip, 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 flip. Right, that is the last one, so we leave that as it is, and then anything else we would just write down zeros. But obviously in this case, there is no more to the value. So that we are saying, because we performed 2's complement on a negative value, that is now hopefully plus 45. So let's check. So let's put some column headings on. 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. So we've got 32 plus an 8 plus a 4 plus a 1. Now I know, and this is how I add these up in my head, that's 40, that makes 5, 45. Okay, So the 2's complement process takes a positive number and gives you its negative equivalent, and it can take a negative number and give you a positive equivalent. Now this is important. If I am given a value in 2's complement, so let me just write down, I'll do a 6-bit value, doesn't matter. So I'm going to do 6 bits. And I say this is a 2's complement value. What is that value? So I'm going to put column headings down. Remember, that's the sign bit. Whenever I'm looking at a number, and as soon as I know what the format is, so someone said to me, this is 2's complement, I look at the sign bit and I go, right, 2's complement. The sign bit is 0, so this is a positive number. So I'm going to write down plus. And because it's a positive number, I can read it. I can read positive numbers. It's just like sign of magnitude. So I'm going to look at this number. I'm going to say 16 plus 4, which is 20, plus 2, which is 22, plus 1. So this is 23. Now, if I was given another number in 2's complement, let's have this one. I'm going to go backwards this time. Right, and again, I'm going to be told it's a 2's complement value. So I look at this and I go, right, okay, looking at that sign bit, it's negative. So I'm going to write down as my answer minus, but I don't know what number it is. It's not -4, okay? It is completely unreadable. So what I'm going to do in order to be able to work out what that number is, I'm going to do 2's complement and find out what the positive version is. So what I'm going to do, 2's complement. So let's go for it. Let's go flip, 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 flip. That's the last one, so leave that as a 1. Anything else we would write down as zeros. Now, that, if we look at this, it's now a positive number, so it's 4 and 1, so that is +5, which means our original number was -5. So you've got to be careful. Just because a question says 2's complement does not mean you automatically flip and add, which is the most common mistake students make. What you do is you look at the sign bit. If it's positive, just read it, like we did with this one. If it's negative, i.e. there's a 1, say, right, okay, then let's just do 2's complement on it. Make sure we wrote down a minus first so that we remembered we were starting with a -5, which is another common mistake students make. They might just write +5 is the answer, but it isn't. So we can say, right, I can't read it, but if I do 2's complement, I can find out what the positive version of that number was. And then that gives me the answer, -5. Okay. Just as a summary of all these integers, if you get something like this, let's just do an 8-bit. 2, 4, 8, 16, 32, 64, 128. I'm not doing this with a mouse, by the way. I've got a pen. I would be a genius if I could write like this using a mouse. Nobody can. Okay, right. So if I had this number, oh, hang on. Let's write down this number. And I said A, it's an unsigned number. Or B, it's sign of magnitude. Or C, it's 2's complement. Or 2C as we often write. That tells me how to interpret this pattern of bits. Okay, if it was an unsigned number, I just add up all the columns where there's a 1. Now in this case, that's the biggest unsigned number in 8 bits, which is, remember, next column heading, -1. So that would be the number 255. Scroll that over a little bit. For sign of magnitude, I go straight to this and I say, whoa, sign bit. It's a negative number. And then I read the remainder of the bits because they contain the magnitude, this bit. Now that would be the largest negative number in 8-bit sign of magnitude, which we know is minus 127, one less than the sign bit column. In 2's complement, we look at it and we go, oh, it's negative, but we then go, whoa, hang on a minute, I can't read it. So what I'm going to do is I'm going to perform 2's complement on it. Now, let me just write this out again. Because I need to be able to do the complement at the bottom. Let's put some column headings on. And I'm going to do 2's complement. So remember, that's flip all the bits until you get to the final one and leave it as a 1. Anything else after that, just write down as a 0. Right, so we're going to flip, 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 flip. We get to the final one and we leave it as a 1. So that is plus 1, which means the negative version of that was minus 1. Minus 1 is one of the most beautiful numbers in 2's complement. It doesn't matter how many bits you have, it will always be all the ones. So you can spot it really easily. But can you see what we've got there? We've got 3 different outcomes just because we interpreted this pattern of bits in 3 different ways. And that's the real essence of data representation. Bits are just bits until we put our spin on it and say that's what they represent. Okay, and everything we do in data representation comes back to that what we say they represent matters. Okay, you can't just take a pattern of bits and know what it represents. You need to know that it's an integer, it's a character, it's a pixel color. Okay, it's part of an encryption key. Whatever it is, you need to know. It might be that these 8 bits are part of a larger number, a 64-bit number or a 2048-bit number. But if we know what it represents, then we can interpret it properly. And the interpretation can be wildly different. Okay. So with 2's complement, let's just recap. Sign bit is the most significant bit. If you're writing down a positive number, just put a sign bit of 0 and then use the remaining bits to write the number down. If you've got to write down a negative value, so write down the positive version and perform the 2's complement, the flip and add. Okay. If we just think about the range of numbers, so the biggest number for 2's complement is going to be a 0 followed by all the ones. So that's going to be positive. So this is 8 bits, positive 127. But actually, the largest negative number is minus 128. And it is the only thing that's a bit weird about 2's complement. So if I've got this value in 2's complement, and I go, oh my, what is that? Now I know it's negative, so I can't read it. So I'm going to perform flip and add. And remember the flip and add. You flip all the bits until you get to the last one. When you get to the last one, you leave it as a 1. Everything else remains 0. So when you start this one, you go, oh, that's the last one. So leave it as a 1. Everything else remains 0. And it stays the same. So that's 128. So this is minus 128. So you can get one extra value in 2's complement as opposed to sign of magnitude. Remember, sign of magnitude, if we read that as sign of magnitude, that would be minus 0 in sign of magnitude, which is a bit nonsense because it's sign, size, sign, size. In 2's complement, it's all embedded. Okay, so in the next video lesson, we're going to look at arithmetic, so how we add and subtract numbers, and we're going to be using 2's complement. Okay.